All right, guys, 4 steps to optimize your database. No, I'm just joking. There is no recipe. Like we see all those videos, that is 2 steps to get strong right away. Like
Yes,
10
from
ways.
zero to hero.
Exactly. So no, but definitely there are some things that we can do to get our database in a better shape.
Yes.
And we want to talk about this today. So Pedro, you want to take it from there, and we will
Yes.
intercept in the middle of the conversation.
Okay, perfect. So the first step is to create make an evaluation about the database to know if the database has waste space, have something that we can just because the database is the place that all of the other objects are connected. So we need to go to the father, to the mother, in this case, and clean up everything that we understand that is wasted, everything that is not used. Sometimes this is an example, when we create a big load of data, a SQL Server or another database create a log about this tremendous loads. So this space is reserved by the database, but never is clean off if we don't clean off manually by ourselves. So, and this is loading memory all the time that the database is running the service and do anything. So in this case, we have a lot of opportunity to get better from the database. This is the first step that we recommended in this case. Okay, the second one is verify the size of the tables. So when we verify the size of the table and the use that they have, we have an opportunity to optimize those tables that are most used, that have more size, and that we understand that are in most of the queries and in most of the uses in the business. So these are candidates that we can use to get some optimization in this process.
Pedro, I will steal the word from you right now for a little bit, because I think that you touch a really interesting point. For example, most people think, especially programmers like developers, for example, if you use an ORM, you think the database should run alone and it should be fast all the time, but it requires maintenance.
Yes, that's
so that can be at different levels. It can be a configuration level. You need to set up how your database is going to grow. For example, one case, I come from an Oracle background in that sense. You can plan how much space will be added to the table each time the table grows. For example, you say, like, I have reserved 100 megabytes for this table, and then you're in 99 megabytes, and the next increase will be 10 megabytes only, and it will continue increasing by 10 megabytes all the time. So all of those things you need to actually take care of. And another thing that happens in Oracle that is less common in other databases is how you handle the file system, because there is some file system restriction. If you have a super big table, we have those cases in the office here, that is, I don't know, 10 gigabytes. So at one moment, it's not even the database anymore. It's your file systems, your permissions over the file system, and a lot of other things. In Oracle, you can handle that. You can handle that also in Postgres and in many databases. But it's not something that you can leave just running, that fire and forget. You always need to take care of the databases and the OS. For example, if your connection is using a host name instead of an IP, every time that you send a query, you need to resolve the host name again. So those little things can affect the overall performance of your database. So it's something more broad than people think. People think about database as a storage, like files, but it's not like that. It can get really, really complex.
Yes. And something very important that you talk about is about the default setting. Because sometimes we install SQL Server, Postgres, and we leave as default setting. And the default setting, we think is working most of the case. We think that, but it's not at all. So, giving an example, SQL Server, when we install SQL Server, if you go to the properties of the instance, you're gonna see that SQL Server set memory use for all the memory that have the computer.
Mhm.
And if you leave like this, as you use a SQL Server, you're gonna take the memory. In some moment, you're gonna have the computer stolen by SQL Server, you know. So
Mhm.
you need to go to this memory setting and restrict the database to a top that you want to, you know, that the database get, and leave resource for the other application. So this is something, giving
To be,
your example, great
to be
example
honest,
that you
Pedro,
give.
I think that this conversation can get like super complex because I just remember one
Yes.
other point, which is memory pagination. The OS do pagination, that is, it takes the chunks from the RAM to the disk. And also that can affect the queries, the reporting and everything. So
Everything,
there are
that's
more
correct.
moving parts that you think. You think it's
Yes.
only your code. No, it's your code, the settings, the OS. So sometimes I'm usually up to do local stuff, more like with AI, I use local models, not the cloud.
Mhm.
But sometimes it's better to just hire Azure SQL and then just use it. They take care of all those things for you. So
Yes,
if you
I
really
just
that's
want
want
to
correct.
to,
fire forget,
and I just want to mention just one briefly thing. The automatic optimizations that Azure SQL recommends are really, really good. So if
Okay,
you turn
perfect.
that on and you
Perfect.
let that run for a couple of days, it analyzes your database and gives you really, really good suggestions. So it tells you, hey, you should create an index here because you're using that a lot. Hey, you should.
Yes.
Uh,
Yes.
So just follow those ones, and that's a good starting point.
Yes. These people is using AI behind the scene to analyze the information all the time, and we don't need to take care of this. Oh, but all the time it's good to go and, like what you say,
And I also believe
and do a little settings
no,
by.
no, but and I also believe it's a matter of also, like, if you think about us, that we have several projects and several students, and we have seen so many things in
Yes,
all
that's
these
correct.
years. Imagine them that they have hosted that amount of databases, and they can start see patterns, okay, every time, like, and they can run those through every database and give you this, okay, do this,
Yes.
you will get good performance out of it. So it makes sense to follow those guidelines.
Perfect. So we can continue with the third part.
Yeah.
Okay, the third part is identify index needed. So when we want to identify index needed, like Javier say, actually do it by itself. If we need to do that, the most important thing is to understand what queries are taking more time, are taking more resource from the computer. So we have to attack the worst. we don't need to attack the simple query that are all the time running good. And if you run a plan estimation, you have 100% just for the query. You need to go to the query that are taking a lot of time, a lot of resource, and then you have an opportunity over there to get some information from this query that you can get optimized. So SQL Server and Postgre and other database have this tool that you can just get the information about the queries that take more time, take more resource, and then you can go to this query and make some research about the query, about how to optimization, and you have common in almost all database that you run the query with estimated plan, and this estimated plan give you an idea in how to handle these new things.
yeah, to be honest, Pedro, there is another point in there in point number 4 that we're talking is that you mentioned that you need to attack the thing that is taking more time. But I will say like maybe you need to attack the thing that is easier to fix for you, whatever that is. Because
Yes,
for
that's
example,
correct.
for me, I will go and check all the OS things and the pagination and the memory of the system before going to the queries, because it's easier for me to handle that part. This is kind of my expertise before going to the planification of the query.
Yes, that's correct.
And there is another point that we can go even back on that place, that is the shape of the data. Sometimes your data is ultra normalized and your database schema is not ready to do reporting. You will always have a slowness, or you will punish the users that are inserting data when other people is reading. So sometimes data warehousing is a good solution. You put everything in a different place, and then you read from that. You put it in the shape that is readable for the reports. Like most of the time, you don't need that star schema. What you need to do is like one simple huge table, especially in systems like ERPs that you want
Yes, that's correct.
the invoices, the credit notes, the debit notes, you put it flat in the single one, and then you do the reporting from that. That will fly. But if you have your ORM schema, like the classes schema represented in your database, that will do the planification of the query like slower.
Yes, that's correct.
Sorry that I
No,
cut you off, Pedro, but I didn't want to lose the
no. It's good. If we want to talk about a data warehouse, this is a topic, exciting topic that we can have in one video, only one video to talk about that. But this is something really important. How the data is prepared for what I'm gonna do with the data in some moment. So this is something perfect. So I think we have covered all the force.
All the
All right. Okay, let's do a quick summarize then. Database cleanup, checking our
Perfect.
sizes of logs and so on. Checking the sizes of our tables, checking our amount of rows, like basically doing a analysis of what you have going on right now. Second, indexes, SQL execution plan, and basically running analysis that checks what are the most used or the most delayed queries, and based on that, we do optimizations accordingly. All right. I think that this is a good starting point. As always, if you guys have questions, don't hesitate to reach out. We love these conversations. That's what we recorded. And see you in the next one.
Bye.